Hello guys, so this is going to be an improvement and tweaking lesson uh, for our simulation and our meshing. I've done a few changes here just to improve the overall sim and to minimize the flickering issue on the rendering stage. So I'll show you what I've done. I really minimized the emission area by shrinking down the curvature with the ramp, and then what I also did is rebake the whole source. You see that it's really subtle. It's not like before. I could have left more particles for the emission, have more particles in the end, but this isn't enough for now. The only thing I did is think ahead for the simulation this time, because what I did last time in my original simulation is using substeps, and I didn't have any file cache nodes. So basically, if we ignore them like this, I went back and reset the substeps to 1 and 2 in the solver, because I realized that I need to substep my collision sources and the volume source as well. So in order to do this, I actually just turned off the flip solver substeps. I went back to the default ones, and I increased the overall DOP network substeps to 4. So I prefer to use these ones when we talk about a simulation like this. We have a really close-up camera, and we need to see that the fluid is really sitting on the surface. But as we remember, if we look at our simulation, it's really fast-moving, fast inflating. There's a lot of changes happening over a few frames, so we need substepping, proper substepping. So the only thing that substeps properly here is the geometry, the SOP that we have here. If we switch to it, you'll see that we have the time warp connected to this. This node is connected to the time warp, so we're live interpolating this geometry source. But what we're not doing by baking this VDB is so basically what we're not doing here is interpolating this VDB along with the geometry. So in order to do this, to do the proper interpolation, we have to save our VDBs and our sourcing in an interpolated manner. So the file cache nodes in the Houdini, I think 17 or 18, were changed and adjusted just so you could cache substeps. So if you look properly in the flip DOP, I set 4 substeps here, and I set the same in the file cache nodes. But the problem with this is the following. So basically, if we do another file cache here, I'll make another folder here. I'll remove what I've done here. I'll come back to this. Let's say I set it to FF. Usually for saving the substeps, you wouldn't use the F, the $F expression. You would use the FF because it represents the fractional frames. And let's see what this does. Like 5 frames, for example. Let's make 5, or even let's make 2 or 3 frames, and I'll save it with 4 substeps. So what will happen here is we'll have this saving window, and you see that it's rendering frame 1.5, then 175, and then this second frame, then 225. It divides every frame by 4, so you have increments of 0.25 frames every time. So for 3 frames, it saved 9. So if we open up the folder, oh, that actually worked. That's interesting, because previously, I don't know if it's like a bug or something else, but previously when I was doing this fractional frame saving, it was actually giving me really terrible, like a bunch of decimal point numbers like this, and a precision error at the end. So this could happen. Really, this could happen with a lot of these SOPs that are set in interpolation mode saving. But in order to avoid this, if you ever have this problem where it just yields you fractional frames with like 20 decimal points after the comma, like if you have that issue, you could fix it by using this expression. So this is a Python expression that properly evaluates subframes, and basically it searches for the current frame of the current node, and it evaluates the this frame as a as an F3, I suppose. It's like a with 3 decimal points afterwards, but I'm not sure about this one because I grabbed it from the Houdini forums, and usually nobody gave an explanation, but this specific expression works really well, and this is what I did here in the saving string. So after the name of your base name of your file, you insert this expression with the backticks. So it will, if you third mouse click, if you like mouse wheel click on the geometry file here, it will evaluate the name of your file. So you're like, if you go into enable playback at fractional frames here, and you right click on this, and you set it to 4 because we're at 4 substeps, you will see that we're evaluating right now at 66.5. And if you go into the name of our file here, it evaluates at 66.5. So yeah, this expression is life-saving if you have that issue with fractional frames. But yeah, apparently on this SOP, or newly created SOP, it works properly, which is really interesting. But yeah, so I saved both the VDB that I had. That's interesting. Apparently, it didn't save properly. I have another version that was saved properly like this, but yeah, so let me find these fractional frames. Yeah, it apparently didn't save it properly. Anyway, usually you would save this, the source, it's saved the same way with 4 substeps with this Python expression. And you can see that it evaluates at every 4th of a frame properly. So if you step slowly, you would see that it's kind of flickering. But yeah, and we have 4 substep overall on the DOP network. Whenever you have fast-moving colliders like this, fast-moving sources, you would need to interpolate and save that with the substeps. So we have the VDB of the geometry saved with substeps because it comes from the time warp. And then you have the geometry. This guy is interpolated live because it comes from the time warp directly, and it's sampled inside the collision source. I mean, not the collision source, but the collider in the static solver here. So it's using the deforming geometry and reevaluating the subs to interpolate geometry. And the third is the source, which is interpolated also with 4 substeps, and it's sourced by the volume source here. So yeah, you have to match these substeps that you have on the DOP network in order to get the proper interpolation for this kind of simulation. So what else? I didn't change much afterwards. I just pushed out the particles after it was simulated. So yeah, the particles are here. There's some particles flowing down on the body. I did the UV texture thing with the camera optimization, so it clips some of those particles. And in the particle fluid surface, I changed the method to spherical. Sometimes it works better for viscous fluids, especially when you have bubbles that you want to preserve inside the volume. But this affects more the flip tanks where you have a bubble pass. And I mean, not a bubble pass, but when you have internal bubbles forming because like an object fell into the volume of liquid, and it creates that like an air bubble after the collision. So this function really saves those bubbles. Usually, if you use the average position, it will kill the bubbles. It will try to fill it up as fast as it can. So yeah. And yeah, I changed some parameters here. The attribute radius to 10, samples to 35 to better transfer the color. I cleaned up the mesh. I attribute casted these guys and saved the mesh. So the mesh is like this. So yeah, this was transferred to my. This color is used by the shader. As you remember, in the symbiote fluid, you have the shader driving the blend between 2 colors. 2 colors for the transmission, and 2 colors for the roughness of the specular layer. So there's some areas that are less translucent than, less refractive than the other ones. So this is cool. And then in the Octane ROP, I turned off the motion blur, and I output some other passes, I think. shading normals, UVs, motion vectors, just in case if we can use it in comp with the real smart motion blur in After Effects. But yeah, that's about it. So the goal of this tutorial was to make something a little bit more unique than what you have on the market nowadays, because I really haven't seen any tutorials concerning these soft body simulations, especially vellum used for creatures and whatnot. But yeah, this is the type of tutorials that I aim to make in the future, and it all depends on how this one is going to work. But yeah, I enjoyed going over this one, and let's. I hope you enjoyed and also learned something from the 3D part of this tutorial. And yeah, let's go to the compositing stage. See you in the next one.